Hey guys, welcome back to AlgoYogi. We are doing two-pointer series. Our third last problem is minimum length of string after deleting similar ends. Let's visit LeetCode and give the description a read. So given a string as consisting only of characters A, B, C, you are asked to apply the following algorithm on this string any number of times. Pick a non-empty prefix. Prefix is what, the string starts with from the string S, where all the characters in prefix are equal. Pick a non-empty suffix from the S, where all the characters in the suffix are equal. So basically you're picking up the clusters of these same string, same character. So for example, here, if C is equal to C, so C is a prefix. And if you were coming across, like, let's say CC, and in the end it was just C, even then that CC is equal to C in the end. Now the prefix and the suffix should not intersect at any index. Of course, makes sense. The characters from the prefix and suffix must be same. Delete both the prefix and suffix. This is pretty much clear. I think I summed it up even while just talking about this. So I think this is going to be really simple. We know what we were going to do, and then in the end just return the minimum length of S after performing the above operation any number of times. But you know what, at the end of the day it's going to be just the whatever the maximum number of operation you're going to perform is going to be just the length. You basically return the length of the remaining string, right? That's what they want. Okay, minimum length of the S after performing all the. Okay, I'm gonna switch the view here and let's see what we're actually gonna do. So for a string, for the example 1, this is the string, and if you're choosing prefix should start over here, suffix would be here, nothing is equal, so we're gonna just return 2. This is the length of S. Now let's come over here. Let's choose something from the front. What's prefix this time? So prefix is, let's say this. It's a cluster of single character, and it could occur just any number of times. So like one character's occurrence cluster is the prefix, and it's in suffix is also the same. These two are same. Then in one operation you can just basically remove these two, so that's one operation. Then remaining string is here. Now again the prefix changes, suffix change, then you can remove these two basically because they're same. Then you're gonna remove B, these are two also same, and then these two are also same. Then you just ended up returning 0 because that's the remaining length of this string. So I think the problem is really simple. It's just you have 2 pointers basically pointing to prefix and suffix, and then you're just making a decision how many of these characters, if they're same, are they same, and if they're same, keep removing until you find different characters from both end. And I think writing code would be really easy. This is going to take big of n time complexity because we're using 2 pointers. So I'm going to just switch the view here, make it look a little nice for you guys, and we can just start writing the code. So we have our string. Let's have our pointers. So left pointer, right pointer pointing to the beginning and the end. Left point to the prefix, R point to the suffix. So length of S -1, the index starts with 0. So what do we want to do? While my left is smaller than or equal to R, I think that's what we want to do. Then I want to check, let's store this that string that we're working right now. While this is the case, and I think left is equals to r, sorry, sr. You know why? Because this is given in the conditions. You can only keep removing until you basically keep finding this prefix and suffix. If you find different prefix and suffix, that's what you return. Even if in the middle of the string there could be more strings matching, you know, in that order. This is different. This is not like palindrome or something. So we're gonna store this. They're same right now because that's when we are moving forward. Otherwise, we will just return the length of the remaining string. Now, while my I would say my left is basically smaller than or equals to r, and my temp is equals to basically L, because I'm going to increment L. So I want to take out the cluster. I don't want to take out just two matching strings. I want to take out the entire cluster. So let's say there is a string S. My first basic prefix is pointing to the letter A, suffix is pointing to the letter A. Then I want to move both of these pointers, take all of them, doesn't matter how many A's you have in the beginning or the end, just take them, all of them out, and move to two different pointers. They could be same again or they could be different. But what I really want to check is, you know, I'll keep incrementing my left pointer until I keep seeing this L pointing to the two suffix and prefix that I just came across, same prefix and suffix in the beginning. And I want to do that to my right pointer as well. So I will just decrement my right pointer. Condition will, you know, just remain same. And instead of checking the left pointer, I'll check right pointer. And in the end, you come out of this loop. You know, either you have just failed this condition, you're coming out, and these two, or you basically just you know, ran out of the string or whatever. Then you will basically return the length of the string. Length of the string is basically r minus L plus 1, because, you know, if it is the index, left is pointing to the second index, right is pointing to the third index, so 3 minus 2, basically 1 plus 1, because there are two characters in that string. So let's zoom out and try to run it. And I think this is a good solution. Oh yeah, of course, you know, we want to increment that. So I don't even know why. These are the solution. One thing that I noticed is you don't want to enter into the loop when these are equal, because the loop, these two will run twice, and at the end you will end up returning, you know, one less value. Okay, so I think now we can submit it, and voila. Okay, let's write the time complexity, which would be big of n. No sorting this time or anything, just simple big of n operation using 2 pointers, bringing them close. It's the worst case time complexity. And space complexity is going to be big of 1, because we're not really using anything. Now let's go back to AlgoYogi, mark this solved, and see you guys later in the next problem. Bye bye.